Hey, what's going on, guys? Today we're going to be talking about wastegates and how it's important in a turbocharged engine. So the wastegate is pretty much the one of the main components, or if not the main component, to boost control. A turbocharger is pretty much it's an air pump. The turbo without a wastegate will produce pressure to the moon. Um, so in order to keep that boost in check, there is a wastegate. There's a couple of different types of wastegates. If you're talking about in the aftermarket industry, more than likely they're going to be mechanical, meaning that they have pressure lines going to them. It's not vacuum, it's actually boost pressure. And like some manufacturers like Hyundai, they have electric wastegates. But at the end of the day, the wastegate only has one job, and that's to control boost pressure. So the way that a wastegate works is, so the first example I'll give you guys is an internal wastegate. Pretty much all factory manufacturing vehicles have internal wastegates. All right, so this is an illustration of a turbocharger. The turbo does have two wheels. You have a compressor wheel, and then you have a wheel. You have a hot side and a cold side. The hot side is where the wastegate's located. So this is an internal type of wastegate. So here you have your turbo. Here is your exhaust wheel. So your exhaust manifold, if it's a four-cylinder, all four runners are spinning this exhaust wheel. And without a wastegate, this just becomes a pump. So if it doesn't have a wastegate or a boost controller, it'll make, I don't know, 100 psi of positive pressure or boost pressure. So that's when the wastegate comes in line in order. So you have an exhaust flap located on the exhaust side of the wheel, and this flap opens up if the computer is set for a maximum psi of 15, maximum psi of like 15 pounds. Then this wastegate uh, exhaust flap will open up. That way the turbo stops building pressure, so it just creates like a big exhaust leak. But it usually goes into the exhaust stream, so you don't really hear it. So these can be controlled either electronically or with actual boost pressure. So you'll have the flap is built into the turbo, and through the center, through the actual turbo, you'll have a rod. And then on the outside of the turbo, you're gonna have another rod to your actuator. So we'll say electronic wastegate actuator. So this is an electronic system. So you'll have your engine control module, ECM. It's gonna be watching your boost pressure sensor. Boost pressure. And this is going to be located somewhere on one of the charge pipes going to the throttle body. So it's pretty much like a map sensor, but it detects boost. Some vehicles still have a map sensor as well. So when the boost pressure sensor sees 15 psi, for example, the engine control module is communicating with the boost pressure sensor. Once it sees 15 pounds, then the PCM will send a command to the wastegate actuator to extend the arm, and then it'll open the flap, and that's how it keeps the boost pressure in line. So that would be a electronic controlled wastegate system. So now, same idea if it's not electronic. So this actuator becomes pressure. It'll have a so your charge pipe, one of your charge pipes will have a nipple on it, and that nipple will run a hose to your actuator, and then from the nipple it'll go to a solenoid as well. So same thing, the computer will detect the desired boost pressure, and then it'll command the solenoid on. So the solenoid opens and it allows boost pressure to come into the actuator, and it forces it open. So that's another form of, it's still considered electronically controlled, but the actual actuator is not electric. All right, so that's for internal. Now we'll talk external wastegate. So some people do upgrade turbos, like in DSM world, which is like Mitsubishi Eclipse. They'll use turbos off of like a big, like a Cummins diesel. Their whole set turbos, HX35 for example. And some of those turbos do have internal wastegate flap. So what they do is they'll weld it shut. So they weld that shut so that flap can no longer open, and then they run a external wastegate. So the external wastegate is usually going to be located somewhere on the exhaust manifold. So if it's a 4-cylinder, that's a pretty gangster exhaust manifold, huh? So usually it'll be located, the wastegate flange will be towards the center of all 4 cylinders to properly be able to control boost. So let's say here you'll have another flange, and then you'll have your wastegate here. So this is an external wastegate. So you'll have your exhaust manifold, and then you'll have your external wastegate. Obviously the turbo is connected to the exhaust manifold. So this can also be electronically controlled by the engine control module via boost control solenoid, or it could just be a basic boost controller, which is a ball and spring type of controller. So if it's a basic ball and spring controller, usually there's a nipple or a barb fitting on the compressor housing, and that will have a line going to the wastegate, and then you'll have a boost controller. So you'll have the pressure source line going to the wastegate, and then one going to the boost controller. Boost controller. So it would actually be routed a little different. So your boost pressure source line will come to the solenoid or the boost controller, and then from the boost controller it'll go to the wastegate. Depending on if it's a screw-in type boost controller, it's just a ball and spring. Once that spring collapses, Then it allows boost pressure to open up the wastegate. And then the wastegate, it's just like a big exhaust valve. It'll just start dumping exhaust gases out to control boost. And same thing would be if you're running like a 3-port or a 2-port electronic solenoid. So electronic, wastegate, solenoid. Same thing, you would have your positive pressure boost source to the solenoid. Once the computer detects the desired pressure, ECM, then the ECM will command this solenoid to turn on and open up so the boost pressure goes through and then opens the wastegate. So the wastegate is the most important part of boost control. Without a wastegate, like I said, the turbo doesn't know when to stop. The turbo is just a big ass air pump. So it'll just build pressure to the moon. So wastegate is your boost controller, pretty much. And I'll attach some pictures of what an internal gate looks like and what an external gate looks like as well. I'll attach it to the video somewhere. Another important part to the turbo system is people call it a blow-off valve if it's an aftermarket. So the blow-off valve is going to be located on the charge pipe going to the throttle body. So here's your throttle body. Throttle body, charge pipe. So you'll have a flange here with the blow-off valve mounted on it. And then same thing, this has a mouth that will open up. And they also have, these usually go to the intake manifold. So under boost, when you're under boost, the intake manifold is under pressure, obviously. So the boost is pushing on the blow-off valve to stay closed. Once you let off the throttle body, then the intake manifold goes under vacuum, and then the vacuum is what opens up the valve to allow that whooshing noise. It's not just for noise, it's actually relieving positive pressure that's left in the charge pipes. If you don't have a blow-off valve, you'll hear the compressor wheel. Hear compressor surge or turbo surge. Is that people think it sounds cool, like a Supra. You smash on it, and then it goes doo 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 doo. That's actually not the blow-off valve. You're actually hearing the compressor wheel. So instead of relieving the pressure, if you don't have a blow-off valve, then the turbine wheel, the compressor side. So this would be the cold side. Remember, there's a hot side and a cold side of the turbo. This is the side that is sending pressure into your intake manifold. When you don't have a blow-off valve, all this pressure goes back to the turbo, and the turbo is spinning, let's say, clockwise. Now, if you don't have a blow-off valve, then that pressure goes back to the compressor wheel and makes it spin backwards, and that's what creates that noise. But that's bad for turbos. That'll mess up turbos for sure. It sounds cool, but it's not. It doesn't make power. It's not a positive thing. If you're hearing a compressor surge, that's what they call it. And like OEM, in the OEM world, instead of the air going out to the atmosphere, they usually have another hose that will route it back more than likely to the airbox boot. So the air intake. So there's a hose that goes to your intake tube that goes back to the airbox. So you're not hearing that swoosh or the psh noise when you let off the throttle. That's in a factory. When you're talking about factory, they keep it quiet, but it's still considered a blow valve. The manufacturer might call it a RCV. They could call it different things. I don't know. Every manufacturer is different. I'm trying to think what Hyundai calls it. RCV valve, recirculation control valve. That's what Hyundai calls it, RCV. But it's still a blow valve or a pressure relief valve. This can affect boost. It's not direct boost control. So it doesn't directly control boost. However, if you have a leaky RCV or blow valve, meaning that this pressure relief port is staying open, then you're gonna have a boost leak. That's just, so when the manifold goes under pressure and this stays open, you're just losing boost pressure, so that's considered a boost leak. So at idle, if you look inside a blow valve at idle, you'll see that the valve is open, since, like I said, it is vacuum controlled. So I'll show you guys on my wife's Santa Fe some of the components I just talked about. Alright, so I know it's kind of dark in here, but so here's your turbo. So this here is consider your cold side, and then this is considered your hot side of the turbo, the side that has the exhaust connected to, or the downpipe, that is going to be your hot side. So your hot wheel is going to be on this side, and then your cold wheel is over here. The exhaust gases do spin the hot wheel, and the two wheels are connected with a rod or a shaft. So when the exhaust spins, it's spinning the cold wheel at the same time, and it's producing pressure, and then the pressure gets sent into the intercooler. So it goes through the intercooler, which gets cold air, located right there. And then once it passes through the intercooler, the air gets cooled down, because it is hot air, even though it's on the cold side or considered the cold side. Once it comes out of the intercooler, it goes into the throttle body right here. So now this whole system is under boost pressure, so you're force feeding the engine. On a naturally aspirated engine, the engine is just a vacuum pump pretty much. So during the combustion events, or during all the 4 cycles, the engine is becoming a vacuum pump. So it's just under vacuum. There's no positive pressure. Now the turbo, you're forcing the engine you're forcing air into it, creating power. So this is considered a charge pipe. And then the blow valve or RCV valve is located down here. It's hard to see. This one does get routed back into the airbox. That way you don't hear the noise, the whooshing noise, when you let off of the throttle. And then this is a internal type wastegate. You can't see it right here because it's so dark, but the wastegate is located back here. And there is a rod that opens up the flap, like I was trying to draw. Like I said, I'm not Bob Ross, but I'm trying my best to explain this to you guys. And yeah, that's just some info on boost control, my understanding of it. And yeah, I hope you guys enjoy the video, and we'll catch you guys in the next one. Peace.